And so let's just think about what's happening when I plug in large values of n. When I'm saying the limit as n goes to infinity, I'm saying n is going to infinity. So n is going to get huge, extremely big. If n is huge, what's happening here? This is 108n minus 1, which is essentially 108n. If n is really, really big, I almost don't even see that minus 1 on the numerator. And the denominator will be 12 times n. So when n is huge, really all that's happening is I don't have that minus 1 there. I don't care about it because the difference is almost negligible. It's like a billion and versus a billion and one. You don't notice, and when n gets even bigger, you notice even less. And so that difference goes away completely. All right, so what's happening here when n goes to infinity is that all I care about are the biggest terms, biggest degree term in the numerator and the biggest degree term in the denominator. The smaller degree stuff doesn't contribute. That's whether it's a polynomial, and then we'll also see that we can compare different functions as well. But for now, the minus 1 plays essentially no role, and this limit will be 108n over 12n. The n's cancel, and I get 108 over 12. Let's see, what's that? 9. 12 times 10 will be 120, 12 times 9 is 108. So that is the limit. Another way that you can look at this is you could plug in values of n. You could plug in very big values of n into this and put it into a calculator and see what you get. You'll find that you'll get stuff that is very close to 9, and as n gets bigger and bigger and bigger, they get closer and closer to 9 as well.